So now we're going to talk about the axis of symmetry. The axis of symmetry crosses a parabola at its vertex. So the vertex is at 0, 0 here, and it's a horizontal line. So let's go back up to the beginning of our lecture here. And if you remember, when I graphed x is equal to -4, it produced a vertical line that crossed the x-axis at -4. So I want a vertical line that crosses the vertex, and I get that by saying that it's the x value here, x is equal to 0. So I have an axis of symmetry, and I'll label it up here, at x equals 0. And the unique thing about this symmetry is if you look to the right hand side of it, it's a mirror reflection on the left hand side. So the interesting thing here is with the axis of symmetry, not only the reflection, but if I travel horizontally from the axis of symmetry out till I hit the graph in the direction to the right, I've gone, let's say in this case, 1 unit. If I go that same distance the other way, I'll hit the graph again. Now, albeit it's in a negative direction, but the unit distance is 1 unit. If I do that, say I pick a spot right up here at say y equal 4, and I draw a line across, and I didn't hit it perfectly, but what you'll see is I've gone 2 units to hit the graph this way, therefore I'll go 2 units to hit the graph this way. So no matter where I'm at the axis of symmetry, I'm halfway between either side, because the distance from here to here is 4, and halfway between is the axis of symmetry at 2. So let's take a look at an axis of symmetry for a different graph here. So let's take a look at this one. What's the vertex here? The vertex looks like it's at 7, 2. So 7, 2 is where our axis of symmetry is, and so I'm going to draw a graph of a line that crosses the vertex and is vertical, and it will be at x equals 7 because that's the x coordinate of the vertex. Again, if I go, let's say if I draw a horizontal line anywhere on here, and it doesn't matter really where I draw it, if I drop a line down, I can measure the distance over from the axis of symmetry, and it looks like I've gone over 1 1/4, maybe 1 1/3 units. If I do the same thing over here, it looks like I've gone over 1 1/4, 1 1/3. Not a perfect line actually, so it looks almost like 1 1/2. Let's try that again. Sometimes these things happen when you draw these lines. They're not going to be perfect. But it looks like I've gone about the same distance from the axis of symmetry to go this way and that way. The nice thing about it is if you find a point up here that you like, you can transfer that point over to this side by counting, it will have the same y value, but it will have an x value different in the way you calculate that. You say, well, how far did I go this way? Say I went 2 units. Well, I'm going to go 2 more units that way, and I'll have the other coordinate. So we can take that back over to here now as well. The coordinate for this particular point is 2, 4, and the coordinate for this point is -2, 4. Notice that the y values are the same. They're on this horizontal line. The x's are different, and I went 2 units from the axis of symmetry to the right to get to this one, so I'll go 2 units to the left, and if I go 2 units to the left, it's just because this is on the origin, it happens to be at -2. So let's take a look at this other graph here. This one's upside down, but again, it will have an axis of symmetry. We got to find the vertex, and it looks like it's at -6, +2. So my axis of symmetry, if I draw it, will be a vertical line, and it's best actually, I know I've been drawing them solid, but now that we've gotten used to this, to draw them as like a dashed line. Because really, we're going to start using these dashed lines to help us graph the equation, but it's actually not part of the equation. It's just a tool to help us do that. Let's just say that I wanted to plot a point, or I found the point, say right here, the point which is going to be -4, -2. Now, if I draw a horizontal line across, I can actually plot that point over here. I happen to know that the y value will still be the same because it's on a horizontal line. I just need to find the x value. Let's see, I went 2 units to the left of to the right of -6 to get my x value, so I went to -4. So now I'm going to go 2 units to the left. So again, it's 2 units each time. If I go 2 units from -6, I should be at -8. And if you brought the line back up here, you'd see that works. Where we're really going to use this technique of finding the axis of symmetry and then plotting points on one side and mirroring them over to the other is when we find the y-intercept. None of these graphs tend to do that, but you will see that we will use the y-intercept. We'll find a point that is the y-intercept and we'll transfer it across to the other side. And then from one point we've actually created two. One last note here, when finding the axis of symmetry, I want to note that we actually use the vertex to find that. Let's scroll back up just for a minute. The vertex is in x comma y. Finding the x value of the vertex is finding the axis of symmetry. So in this case, the axis of symmetry for this graph would be at x equals 2, and you would label that as such. So when asked to find the axis of symmetry, if the graph is in standard form, you actually use this formula right here, x is equal to negative b over 2a. So we're going to apply that down here now. It says find the axis of symmetry for these equations. Well, you need the vertex, or you need the x value of the vertex. And in this case with a, it's in vertex form. So we can spot the x value and the y value of the vertex. So in this case it will be negative 2 comma negative 3. The axis of symmetry then is x equals negative 2, and then you want to label it as axis of symmetry, and you can abbreviate it as SYM. That would be just fine by me. On this next case, it's not as easy. We're going to need to use this formula, the negative b over 2a, which helps us find the vertex to find the axis of symmetry. So the first thing I want to do is state what my a, b, and c are. In this case, a is 1 because there's no number written there, so it must be 1. B is at negative 4, and c is at 7. So I just plug them in, and I get negative 1 because it's a negative, sorry, not negative 1, negative 4 over 2 times 1. So then we end up with negative negative, which is positive, 4 over 2. We get an axis of symmetry at 2. So x equals 2 is the axis of symmetry. Here's the other thing too. We're already halfway to finding the vertex. If I plug the 2 back in here, I'll find the y value for the vertex. So finding the axis of symmetry is halfway towards finding the vertex. The axis of symmetry again is the line that cuts the parabola right in half perfectly and makes a mirror image on either side. I mentioned that we're going to use the y-intercept to help mirror points from one side to the other. So let's start talking about how do you find the y-intercept with the parabola. So the y-intercept is actually not that bad to find. One thing you want to remember about the y-intercept, doesn't matter what graph you're using, the y-intercept has x equal to 0. If x is equal to 0, then the graph crosses the y-intercept. So all we need to do is take our equation or our functions and plug in 0 for x to find the y-intercept. So then I get f of 0 is equal to 2 times x plus 2, I'm sorry, and that's not going to be x, it's going to be 0 plus 2 squared minus 3. So let's see what happens here. I've got, really now, 0 plus 2 is 2, and so now it's 2 squared minus 8. So then I plug in, I simplify some more, and I get 2 squared, which is 4, 2 times 4 minus 3, and then I end up with f of 0 is equal to 8 minus 3, and that f of 0 is equal to 5. So the y-intercept, it's not a number, it's the point 0, 5. In other words, this graph, this particular one, crosses the x-axis at 0, 5, and we can test that. Let's go back in here and we'll turn off the second equation. I do that by highlighting the equal sign and hitting enter, and I enter down, and then I type in 2 parenthesis x plus 2 close parenthesis squared minus 3. And it looks like it crosses the y-intercept at 0, 5. It does look like we're close, so we did a good job. So let's find a couple more y-intercepts. Let's find the y-intercept over here, and again I'm going to find the y-intercept by plugging in x equals 0. So we'll first write the equation. So then I have f of 0 is equal to 0 squared minus 4 times 0. So 0 squared is 0 minus 4 times 0, which is going to be 0. So f of 0 is equal to 0. The y-intercept in this case is at 0, 0. And again, let's test that out. So I'll graph that function. Turn off the one we just used. And I plug in, oh, I can't see it. Let me scroll over here. X squared minus 4x. I hit graph, and it should cross at 0, 0. Yep, the graph crosses. It looks like the y-intercept is at 0, 0. Alright, let's do that again over here with this next problem. So, again, the y-intercept, or as I abbreviate it as y-int, is that when x is equal to 0. I don't want to run a room, so I'll give myself some more space. And I get f of x is equal to x squared minus 4x plus 4 when x is equal to 0. So see, I plug in f of 0, and I get 0 squared minus 4 times 0 plus 7, and then I end up with f of 0 is equal to 7. So the y-intercept is 0, 7. Over here, we'll do the same thing just to test it out. And you can graph these if you want to. I won't graph the last two, but it just shows you how this really works. So let's find the y-intercept here again. I'm going to plug in x equals 0. So the first thing I do is I write the equation. And I tell you what I'm going to plug into it. Then I plug it in. So the y-intercept here is at 0, negative 3. So now, we've talked about the axis symmetry, the standard form, y-intercept.